So welcome students. In this question, you're given that you have a triangle ABC whose coordinates are 4, 4, 8, 4 and 4, 8. And PQR are midpoints of the sides of the triangle ABC. So if that is so, for the triangle PQR which is formed, the orthocenter of this triangle is given as alpha comma beta, and you're asked to find the value of alpha plus beta. So what is the concept underlying this question? The first thing that you need to observe is that the given triangle is a right angle triangle. That's the first thing that you need to observe. And the next property that we are going to use in this question is that if you have a triangle, so if you have any triangle, it is necessarily need not be a right angle triangle. If you take any triangle ABC, and if you form the triangle whose vertices are midpoints of the sides of the triangle, let this be DEF. Now if I want the orthocenter of the triangle DEF, so what should I do? Orthocenter is nothing but the point of intersection of altitudes. So if I draw the altitude from D, and the altitude should pass through D and should be perpendicular to EF. But from midpoint theorem, because E and F are midpoints, this side is parallel to BC. This EF is parallel to BC. So if this angle is 90 degrees, this angle should also be equal to 90 degrees. Now the altitude of the triangle DEF is nothing but a line which is perpendicular to the side BC and passing through the midpoint of BC. So this altitude is nothing but a line through the midpoint of BC and which is perpendicular to BC. That means this line is nothing but the altitude of triangle DEF is nothing but perpendicular bisector of triangle ABC, right? So if I draw the altitude from F, so I have to draw a line through F which is perpendicular to D, right? So this angle is 90, but DE is parallel to AB. So if this angle is 90, this angle is also equal to 90. So now this line is passing through the midpoint of AB and is perpendicular to AB. That means this is again a perpendicular bisector. And similarly, this altitude is also a perpendicular bisector to side AC. So wherever these lines intersect, that is the orthocenter of triangle DEF, but it is the circumcenter of triangle ABC. So the logic that I am going to use is orthocenter of triangle DEF is same as the circumcenter of triangle ABC. Orthocenter of triangle DEF is same as circumcenter of triangle ABC. Now let us use the same concept here. Now PQR is a triangle formed by midpoints. The orthocenter of triangle PQR is same as the circumcenter of triangle ABC. And what is the circumcenter of triangle ABC? ABC is a right angle triangle. If it would have been an arbitrary triangle, I would have to calculate the circumcenter by calculating the point of intersection of perpendicular bisectors. But here this is a right angle triangle. So what is the circumcenter of a right angle triangle? So the circumcenter of a right angle triangle is nothing but the midpoint of the hypotenuse. So you just need to find the midpoint of the hypotenuse. That will be the orthocenter of the triangle PQR. So the midpoint of the hypotenuse is nothing but 8 plus 4, 12 by 2, 6, 6. So this is my alpha comma beta. So alpha plus beta is equal to 12 is the answer to this question. So you can also analyze this question in a different way. That is, so now P and Q are midpoints of BC and AB. So PQ is parallel to AC, right? Similarly, R and Q are midpoints of AB. So RQ is parallel to AB, right? So now the angle between AC and AB is 90 degrees. So the angle between PQ and RQ should also be equal to 90 degrees because this is a parallelogram. These two sides are parallel, these two sides are parallel. So PQRA is a parallelogram. Hence the opposite sides are equal. This angle is 90 implies this angle is also equal to 90. That means this triangle is a right angle triangle, and the orthocenter of right angle triangle is the right vertex, which is same as Q. So I can use this logic also to see that this point Q is the orthocenter of triangle PQR. Thank you.